Now we're going to talk about beta decay. This is the symbol for beta decay. A beta particle is just an electron. That's why its symbol is an E. So what happens in beta decay is kind of weird because what happens is when you have your nucleus, you have protons and neutrons in there. Well, one of those neutrons turns itself into a proton. So one of those neutrons changes into a proton. And when that happens, an electron is emitted from the atom. So the electron is our beta particle. But that happens because a neutron converts itself into a proton. So since we have a neutron turning into a proton, that's going to not affect the mass at all. The mass is going to stay the same because the proton and a neutron weigh the same. So the mass stays the same. That's also why we have a 0 up here. Remember, that top number is the mass number. So since that mass number stays the same, this is going to be 0. And the atomic number on the bottom is -1. And that's because that atomic number is actually going to increase 1. So remember up here when we had 2, that means two protons are being given away, which decreases the atomic number. So in order for this to work out the opposite way, for it to increase, this has to be a -1. It'll make sense when I show you the nuclear equation. Since a beta particle is just an electron, that's a lot smaller than an alpha particle, which means it's a lot harder to stop. It can get through a lot of things. In order to stop a beta particle, you have to have metal to make it stop, which means it can pass through paper, it can pass through your skin, and it can be harmful. Something as thin as a sheet of aluminum foil is enough to stop a beta particle, since aluminum is a metal. So let's say we have a nucleus here and it has 4 protons, they're green, and 4 neutrons that are white. So if it's going to undergo beta decay, that means one of its neutrons is going to turn into a proton. So after the decay, we should have 5 protons, but only 3 neutrons. So one of those neutrons turned into a proton. Now, I'm not going to show anything here. I will put this here to stand for our electron, but remember that electrons aren't actually in the nucleus, so I shouldn't actually really need to show anything here, but this will represent our electron that's being emitted. Now we'll look at another nuclear equation. So let's say we have cobalt-60 undergoing beta decay. So here's our starting atom, the cobalt-60. We need to figure out what that cobalt-60 turns into. I'll just draw a box and we'll fill in that box. We're going to figure out what cobalt-60 turns into whenever a beta particle is emitted, and there's our symbol for beta particle. Once again, I'm going to separate this into 2 math problems. I have 60 is equal to something plus 0. That means 60 is going to stay 60. And 27 is equal to something plus 1. Oh, sorry, that should be -1. So 27 is equal to something plus -1. So if we're adding a negative number to get 27, that means this had to have been 28. 28 plus -1 equals 27. So now we can look back and see if this makes sense. So we said the mass number stays the same, so that top number did stay the same, and the atomic number increases by 1. So 27 increased to 28. Now that we know that the atomic number is 28, the number of protons is 28, we can look that up on the periodic table. And the symbol on the periodic table for number 28 is Ni for nickel. So that would be our full nuclear equation.